Okay, I'm gonna get started by just hitting the timer. The timer is hit, so let's get started. Let's take a look at the first question. Okay, I'm gonna do it on the right side here. It's a bit tricky, hang on. Oh no. So, number one. Gonna be using this space here. Okay. Fx equals 2 sec x plus 6x minus 3, and the domain there, the equation fx equals 0 has a single root, alpha. Show that, yeah, the root is within 0 and 0.1 and 0.2. So the way we do this is to use the numerical method, where we just substitute the bounds of the interval. So the first one is 0.1 substituted in. So it's going to be 2 sec 0.1 plus 6 0.1 minus 3. And we're going to just do another one. F 0.2 equals 2 sec 0.2 plus 6 0.2 minus 3. So we expect a change of sign, right? So I'm going to just do in my calculator here 2. And then sec is 1 over cos, right? So I'm going to do 2 divided by cos of, got to do radian here, 0.1, close bracket, then close bracket again, and then plus 6 times 0.1, and then minus 3. And that would give me a minus, right? So that's a minus 0.3899, blah, blah, blah. And the other one, I'm just gonna edit the thing here. So, I can't really change that. So, yeah, this is not a usual calculator we should use. 0.2 plus 0.6, plus 6 times 0.2 minus 3. And there we have a positive number there. Blah, blah, blah. So there is a change of sign of fx where fx is continuous in the interval 0.1 to 0.2. Therefore, we conclude that there is a root in between. So there is a root alpha in that interval, right? So that's normally how we do a numerical method. That's very easy. And that's done for A, yeah? So for B, show that the alpha is the solution of this. So basically for this question, we just need to rearrange this original function and make somehow x the subject, right? So you can see here we have 6x here. So that's our hope, all right? So I'm just gonna, hang on, let me just change the orientation of the page a bit. Okay, so I can scroll down. So from the question on the left here, I have fx. So if I make it to 0 first, so we have 2 sec x plus 6x minus 3 equals 0. That is to find the root of fx equals 0. And then if we isolate x, right, so we're going to have 6x equals 3 minus 2 sec x. So just make 6x the subject. And then we make x the subject, so we divide across by 6, so we get 1 over 2 on the first term there, and 1 over 3 sec x. And as you can see, the 1 over 3 sec x there is just 1 over 2. So this is 1 over 2 minus 1 over 3, and then cos x here down here, yeah? I need to get some stuff. Give me 5 minutes, I'll be back. Some arrival. Okay, I'm back. Sorry, just some parcel arriving. And here we go. Yeah, so now we just have the form here. So we can say therefore xn plus 1 equals 1 over 2 minus 1 over 3 cos xn as required. Yeah, and that is our iterative formula. Wait, actually we don't have to write that yet. We just got that because that's the next question. Okay, so the next question C. That iterative formula is used to find alpha. So starting with x equals 0.15 and using the iterative formula, find the 4 decimal places, the value of x2. So that's going to be a little tough for me because, yeah, let's try. Not sure if this calculator will do the job, but so let's put 0.15 as the answer first. So I'm just going to hit equal sign here. And you know what? I'm just going to use this. I'm just going to use this calculator instead. So 0.5 as an answer. And then, 0.15 as an answer. And then 0.5 minus, 1 over 3. Gotta be doing in radian here. No, in radian. Okay. Cos, where's cos? Cos answer. Okay, so that's the answer for the first time. So I here, 4 decimal places. So we get x2 equals, just have to write the working a little bit, 3, and then cos 0.15 here, So this will be 0.1629. Or we can do 8, blah, 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 and then we round it to 0.1629 for decimal places. And then number 2, we're gonna find the 4 decimal places, the alpha. So that is when we just keep pressing the equal button until it converges. I'm just gonna do very quickly here. And as you can see, it stops at 0.1622, as 4 decimal places there, if we keep pressing the button. Okay, so that's done for number 1. So number 2 here. Okay. The weed on the surface of a pond is being monitored. The surface area of the pond covered by the weed A square meter is modeled by the equation. It's a log equation, where t is the number of weeks after monitoring began. Use the equation of the model to answer part A and B. Find the surface area of the pond initially covered by the, by the weed. Okay, so just part A here, right? Initially means t equals 0, right? So we're going to do log 10, you don't need to write 10 at all. It's just, you can write log A here, equals 1. If we sub 0 in, it's just gone. So A would be equal to 10 to the power of 1. Because you can do it's log base 10 here, so 10 becomes the base of the index 10 to the 1 here. It's like moving the base to the base on the other side. So we have A equals 10. Okay, so 10 square meters. That's it. So part B. After t weeks, 25 square meters of the pond is covered by the weed. Find the value of t, giving your answer to 2 decimal places. Okay, so we need to 25 square meter here. We need to plug in the log equation like that. Just plugging A as 25 here equals 1 plus 0.03 and then the big T, because we are finding big T here, number of weeks, right? And we just solve for T, right? So basically, let me see. We can solve for T already. So T is, if we make T the subject here, as you can see, we have log base 10 of 25, which I don't need to write 10, minus 1, or divided by 0.03. So we can do in a calculator here, log 25 minus 1, and then all divided by 0.03. So that would give us 13.264 dot dot dot, and if we make that to 2 decimal places, we get 13.26 weeks, right? So that's the answer there. Done. Let's do number 3. Okay, number 3 here. Let me just change that as well. Okay, so number 3, a curve has equation that use calculus to find the range of values of x for which y is increasing. Well, basically, we want to find the rate of change of y respect to x, and that is done by differentiating y respect to x. So we find dy by dx, right? Derivative function. So here it seems like we might need to use a quotient rule because we have an algebraic fraction. Maybe easier to use a quotient rule. So quotient rule is v du minus u dv. So v is the bottom, du, we differentiate the top, we get 4, just by the power rule for differentiation there, minus u, which is the top bit, dv, yeah, dv is differentiating the bottom bit, so using the chain rule, we bring the power down, and the thing here remains first, and the power gets subtracted by 1. And then we differentiate the inner function, which is x plus 3, we get 1, so I just don't need to write anything there, just keep it as that. And then all divided by, according to the quotient rule, we all divided by the bottom bit squared, so that will bring the power to the 4 instead. Yeah, let me just check through that. Okay, I think I'm happy with that, so keep on with that. So we, you know what, we don't need to do anything yet, because at the end of the day, we want to do something with this, right? So it's like, it doesn't ask you to find dy by dx. So why do we differentiate? Because we want to put this to greater than 0, because that is where the function is increasing. Yeah, so we do dy by dx greater than 0. Okay, so the whole thing here, greater than 0, if you imagine, you got to put greater than 0 on the right here. And that makes the bottom bit here disappear, because you can multiply across by this thing to undo that on the bottom, because this is always a positive number, right? So that doesn't matter. That means I can do x plus 3 to the power of 2. I write 4 in front here. And then here I have minus 2, just tidy up a bit there. Like that, greater than 0. I already moved this to multiply 0, right? Okay, so that's what I got now. So we want to find the range of this. Well, the clever way to do this is to observe before you do anything. So you look before you leap. X plus 3 here is a common factor of the whole algebra here. So we take it out. So we do x plus 3 here, and the first group will be left with 4x plus 3. The second group here will be left with minus 2, 4x plus 1, right? Because we don't want to expand all out that much, because we want to factorize at the end anyway, so why not factorize first? That would be my technique. So we have x plus 3, and then inside here we would have 4x plus 12, just expanding all out, minus 8x, and then minus 2. Don't forget the minus sign here. Greater than 0. Keeping on with that, we have x plus 3. So this is minus 4x and plus 10, right? So because this is a negative x factor, we need to make it positive. So the way to do that is maybe if I sort of like divide by 2 across, for this bracket here, I get divide by minus 2, I mean, to make it positive, yeah? So I get 2x here and minus 5, right? But when we do that, the sign must be flipped like that, because this is the way inequality works, right? So now we got this. So how do we take this forward? Well, we got to find the range that this is true. So, well, you have a couple of ways to visualize this to get the answer, but I would say you get the critical values. So you have a minus 3 here to make this brackets go to 0. And you have a 5 over 2 here as a critical value to make this second brackets go to 0. and then you order them in a number line. So -3 is less than 5 over 2 there. And because this is a less than sign, so you gotta take the range in between. So I represent my diagram here by the number line kind of way. So the hollow circle here means that you cannot take -3, because if you do, then it will become 0. But this doesn't have the equal sign in the inequality, so we cannot take -3. And that is the range for which y is increasing, because it makes the derivative satisfy this inequality, right? So we will answer, so yeah, we can just do x less than 5 over 2, but greater than -3, right? And I think that's it. We can check later if we're not happy with this, but I'm just going to go do question 4 now. Okay, question 4. Let me change that too. Okay, so question 4a, what do? We find the values of constants a, b, and c, and this is kind of like you are asked to kind of do a long division first, maybe. So long division would be easy, but you can do something else too. You can multiply across by x squared plus 4 on both sides, and then you will compare coefficients. That's also doable too, but I'm just going to go do long division, all right? It's more fun to me, actually. So let's do long division. There you go. So I have 4x cubed plus 2x squared plus 3x plus 8. And we're going to actually divide that by x squared plus 4. So the first term, we divide x squared into 4x cubed, so we get 4x. And we multiply back 4x to x squared, we get 4x cubed. And that's the point, we need to cancel out the first term. And plus 4x multiplied 4, we get 16x. Well, it seems like we are skipping a term here, so I'm just going to move that to this. And we probably need to write 0x squared here just to avoid confusion. The first layer is done. We need to subtract these two. So we get 0 there. The first term is gone. And then 2x squared minus 0x squared, I get 2x squared here. 3 minus 16, I get minus 13x. And this is the second layer, so we can pull 8 down. And then we carry on with the repeat process here. So we divide x squared into the first term here. We get 2. So we plus 2 here. And we multiply back, right? So that's 2x squared. And then because this is 2 multiplied 4, we get plus 8 here without any x term here. And then that seems to be done. We need to minus these two. So we get minus 13x here and 0 for the 8s. And that's the remainder, actually. So here is done. So it's like a is going to be equal to the quotient part. So this whole thing is the quotient, which is ax plus b. So a must be 4 and b must be 2, right? Because that's 4x plus 2. So ax plus b, we compare. And c must be the remainder, cx plus d is the remainder part, which is just minus 13x. So c is minus 13 and d should be 0. And that's all it is. Well, we already showed that d is 0, right? Because this is 0 here, just by long division. Done. That's a and b. So I'm just going to write, d is 0 from long division. Yeah, just to make sure we write the answer there. Wait, hang on. This is not b, it's ii. And this is ai. Okay. Now b. Hence using algebraic integration to find that. All right. So from that, we can now write integral a x plus b. Yeah, that's it. And then plus minus 13x up here divided by, that's the c and the d, x to the 2 plus 4 and then dx. Yeah, we want to integrate all that, right? And don't forget the bounds, so 1 and 4. Okay, here we go. Yeah, we want to give the answer in terms of ln 2 there. Okay, so I'm just going to carry on down here. Let me move that down a little bit. You know what, I'm just going to cut and then copy here maybe. Paste here. Okay, here we go. So this is equal. Yeah, you know, we're going to integrate already. So that's 4x squared over 2 just by the power rule. So that's 2x. Integrating this thing, well, I think we require some reverse chain rule. So let's do it here. I'm just going to move everything down because we might want to do that first. So integrating minus 13x. So, okay, before we integrate, right, we can see that if we differentiate the bottom bit here, we kind of get 2x, which is kind of the same type of function as something x here. And that is where reverse chain rule is going to do the job here. You don't have to do any P4 way. This is P3. So reverse chain rule is possible. And what I mean by that is that when you have integral of something that is derivative over its original function like this, yeah? So it's like if you try differentiate the bottom bit, you get kind of like the top bit. And we'll see how to exactly do this to get the proper answer. You should try some factor times ln of the bottom bit. And of course, plus c. Yeah? So as we can see, if we try differentiate the bottom bit, yeah, this is differentiating the bottom bit, we get 2x. But because we are out by some factor here, because this has to be minus 13, so if we multiply by minus 13 over 2, you know, just the trick, just to cancel the 2 here and make it actually minus 13x. But we got to do on both sides, right? So we got to do that as well. And this very factor will be your factor k, because it's called a correction factor here. And that's the very key technique here for reverse chain rule. So that means, yeah, bear in mind, that means, hang on, we get the integral of minus 13x over x squared plus 4 here as minus 13 over 2, which is the k factor here, and then ln absolute x squared plus 4. That's it. So we can use that integral result when we integrate this separately later on, right? So I'm going to just do that. So I'm just going to substitute that whole integral because we're going to integrate this as well, right? So that would be minus 13 over 2. And then ln of absolute x squared plus 1. Okay, so that's it. That's the integral of the whole thing. And we can tidy up this. We put 2 instead. We put the square brackets and we put the bounds. And then we will substitute. Okay, so the way I would just substitute this is to do something like 2 and then 4 squared minus 1 squared. If you have seen my earlier walkthroughs, then I always do this, yeah? And then plus 2 and then sub 4 in, sub 1 in, you minus in the 1 brackets. And minus 13 over 2. Well, the ln here, because imagine if you do its own subtraction for the ln term. The ln will actually do a division instead, right? So we can do so this is 4 squared plus 1, and because it's like you have another subtraction for ln, so that will be dividing instead using the log property, right? So it will end up like ln of 4, for example, if this is a and then you have ln a and then the other one is ln b, so it gets a division instead. So I'm just going to go and substitute here. Yeah, so that will be it. So see what we get here. So this is 15, so we get 30 here, yeah? Plus, so this is 3, this is 6, and minus 13 over 2. So ln of 17 on top divided by 2 here. Well, we have to answer in terms of ln 2. Oh, we're in trouble. How do we do that? Wait, did I get anything wrong? Oh no, I wrote wrong. Sorry. This must be plus 4. Okay. Because I spot that this is not going to be easily simplified. Sorry about that. Almost flopped. So this is 16 plus 4 is 20. And then this is 1 plus 5. Sorry, 1 plus 4 is 5. So that becomes ln 4, which is much easier now. So that is 36. And then you minus. So ln 4 is basically ln 2 squared, ln of 2 squared. And then you can bring 2 in front, right? So imagine this is 2 to the 2. And then you pull 2 in the front. Cancel with the 2 here. You get 13 ln 2. Yeah? So that would be my final answer there, which is what it wants, integers. All right, so we go do the question 5. I'm just going to use this space here. Question 5. Now we are at 25 minutes. All right, which is fine, I guess. So A. A hot piece of metal is cooled by dropping into water. The temperature H degrees of the metal T minutes after it's dropped into water is modeled by the equation. Use the equation to model the answer part A to D. Find initial temperature, easy peasy. So we just do T equals 0, always, initial. So H equals, when T equals 0, the power of the exponent there will be a 0, and that makes it 1. So that is 280 plus 24, which is 304. 304 degrees Celsius for the first one. B, on diagram 1, wait, where? Diagram 1. Sketch the graph. Okay, here we go. Diagram 1 is here. Sketch the graph of H against T on your sketch. State the equation of the asymptote to the curve. Well, the basic of this is that you need to know that a normal exponential function y equals e to the x looks like that. And that is the y-intercept there is 1, right? If you put x to 0, you get 1 there, right? So we want to plot that kind of function in the question. It's like you can use transformation. But first thing first, if instead of a plus x, you get a minus, like a minus t right there, you need to like flip, yeah? Flip them, reflect into the y-axis. So you get something like that, and this is y equals e to the minus x. So we are looking on something like this function right here, yeah? Okay, so how do we plot this one? So we can say first that it's gonna be looking like this, yeah? And I'm just using the snapping tool here for the app. And at first, the y-intercept here will be, so if there is no 280, it would be 1 still. But there is 280, so it's more like the initial point. So this is 280. But because you're moving up by 24 and the asymptote will be moved up as well, now the asymptote is at y equals 0. It's like the h equals 0. If we move it up, 280 will be changed to 304 as the initial temperature that we calculated in A. And then there is a asymptote here along this line. Okay, and for the sake of asymptote, I should do like this, a dotted line, yeah? And then I say this is H equals 24. It's just the temperature it never reaches, in theory. And that's done for B, yeah? So for C, we're gonna find the value of T for which H equals 144. So we put the whole equation to 144 like that. And then we just solve for T, right? So minus 0.05 T plus 24, right? Okay, so we subtract 24 both sides. We get 120 here on the left, right? And then 280 e to the minus 0.05 T. So e to the minus 0.05 T is equal to 120 divided by 280. Okay, if we simplify that fraction, we get 3 over 7, just cutting out by 40. Yeah, simplifying by 40, yeah. So minus 0.05 T, again, just do the log trick where this is the base, is a natural log base. So base E, if you move base E to the base on the other side, it will become a natural log base, which is ln. Yeah, so you get ln 3 over 7. All right. We want 2 decimal places, so we're just going to use a calculator there. So this is a T value equals, yeah, I'm just going to do it in a calculator here. ln, hang on, ln brackets, sorry, fraction, 3 over 7. Ooh, I think I have to do, yeah, this first, maybe. Like this, 3 over 7. Oops, how do I undo that? Hang on. Okay, here we go. And then divided by minus 0.05. And that is the answer there. T, we want to two decimal places, so 16.95 as the answer. And this is, what's the unit? Minutes. Yeah, so minutes. There you go. So next part, D. Okay. D, show by differentiation that dH by dt is a plus bh. So, okay, we just differentiate, nothing hard here. So differentiating the exponential function, we get the same thing, but we need to do the chain rule on the power part there. So it's 280. So we bring the coefficient of the power down to multiply with whatever is already there. And then everything else remains the same, like that. 24 goes away because when we differentiate 24, we get 0. All right, so 280 times minus 0.05, we get minus 14. So that is minus 14 e to the minus 0.05 t. Now, we're not done because we want to make in the form of something not what we have here. And this is not that hard. If you make some observation here, this is the thing that it doesn't have in the final form that it asks us to derive. So you go check, how do you eliminate this? Well, if you look at the original equation of h equals 280 blah blah blah. How about if you isolate this from the original? Yeah? That is done by just moving 24 on the other side like that and divide across here by 280. I'm just isolating what I don't want here, and I'm going to substitute that into what I had earlier in the derivative function right here. So dH by dt is equal to minus 14, and then we sub the whole thing into that to eliminate the exponential term. Just like that, yeah? So we go down here. So we have dH by dt equals, so if you multiply everything in, yeah, so you get minus 14h over 280. And then there we do 14 times 24, right? Now I'm just going to do this. 14 times 24 minus cancel, yeah? Because minus minus times. Okay, so here we simplify. We got 1.2 here, so the A is going to be 1.2. Right? So this term will give you 1.2. The calculator is showing that. And the other term, we do a minus here. So that's, 14 divided by 280. So 0.05. Doesn't have to be integer. It doesn't say that. So I'm just going to stick to these, A and B. And that is my answer. Yeah? Okay, there we go. Done. Number 6. We are at 34. We have an hour left. Okay. Number 6, given that fx equals that, find f inverse. And always remember to find the domain when it asks to find the inverse, right? Always. So typically we just substitute x as y and y as x. So fx here being y, so we sub x instead. X equals 4y plus 3 divided by x minus 2. Just to show the working here, guys. Sorry, that should be y. Right? Hang on, let me change that to stroke. And then we multiply across there to try and get y as a subject of the equation, basically. Yeah, so we pull together the y term here. So I have x minus 4y. It's like I subtract 4y on the other side and pull y out. And I have here, if I move 2x to the right side, I get that. So y is going to be equal to 2x plus 3 all divided by x minus 4. And so that inverse function is just that, yeah? It's just that. Now again, I actually made a mistake before about this because I forgot to find the domain, right? So we want to find the domain of this. And now you got to know that the domain of the inverse is basically the range of this. So we are aiming to find the range of the f. Now to find the range of the f, well, basically the original function doesn't specify any domain. It just says that x not equal 2, and that is trivial because x cannot be 2 anyway, because if it was, then that would make something undefined. Division of 0 here, we cannot have that. So if only x cannot be 2, then we are quite free in terms of our range. So the trick is to just take the coefficient of the x on top divided by the coefficient of the x on the bottom, which is 1. So that's 4 over 1, which is 4. That is just the value of y that fx cannot take. So it's just, this one is just range of y not equal 4. And that will be the domain of our inverse, which is trivial because if you think about it, it's already our bottom bit here. I'm just trying to make you see here that they link, right? So x is not, this is 4 in this case. And that's it. Okay, so now we are doing b. B, we want to show that f of fx is a similar kind of function there. Okay, so we're just going to put the whole f into the x in the function f. It's like just putting itself into itself, if you know what I mean. Okay, so we have 4, and then you substitute the whole fx in, basically, just like that. Yeah? And plus 3 here. So that's just the beginning of the work there. Okay, just substituting everything in. Yeah? And our job is to simplify. Now note that you might have the same denominator as the top part, the whole top part here, and the whole bottom part here. So we can later on cancel out that x minus 2. So let me show you how. The way we do that is to make denominator the same for this whole fraction and this fraction. I mean, this is 3 over 1, right now. So I'm just going to multiply 4 in there. So I get 16x plus 4 times 3 is 12. But then if you do the denominator here, x plus x minus 2, I got to multiply that, right? It's like I multiply x minus 2 top and bottom right here. So I would get plus 3x minus 6, right? Just multiplying x minus 2 there. And then all divided by x minus 2, don't forget. Yeah? And then on the whole denominator part, like the big denominator, I'm just going to do longer fraction line here. We have similar thing. So we again need to make this the same as denominator. We multiply by that, top and bottom to 2. So we get 4x plus 3 because that doesn't multiply anything. Got to be careful with the minus sign here. So x multiplied 2, we get 2x, but we do minus, so minus 2x. Minus 2 multiplied 2, we get minus 4. With the minus sign here, we get plus 4. All divided by x minus 2. And as you can see, as I said, x minus 2 will cancel here. So we are just left with, just going to write the left-hand side again. So if you simplify the top bit, you get 19x here for the x term. And plus 6 for the top bit. Yeah. And then the bottom bit, you get 2x. And then plus 7. Right? So that's done for B. For C, the point 3, 15 lies on the curve with equation y equals fx. Find the point to which P is mapped when y equals fx is transformed to the curve with equation y equals to fx, f of 3x plus 8. So basically, this is transformation. So 2f 3x plus 8. What are the transformations here involved in this? Well, my general technique is to look from the inside out. You look from the closest to x first. So the first order is to well, let me just order, right? So fx here goes to f3x first. So this is multiplying 1 over 3 to the x coordinates. X here means x coordinates, right? All of the x coordinates will be multiplied by 1 over 3. Because when you have 3 times in the x there, it's doing the opposite in terms of transformation. You got to know that, right? And then we have what? We have 2 multiply outside. That is going to multiply 2 to the y coordinates. And then we have a plus 8 here after everything. And that is going to shift plus 8 to y coordinate as well. So I do y plus 8 here. So what do we have? We have from 3, 15. We start from 3, 15. After the first bit, we multiply x by a third. So we have 1, 15, right? 3 multiplied by 1 over 3. And then we multiply by 2 to that. So we get 130. And then we plus 8, we get 138. And that's it. So the P will be mapped to P prime 138. And that is done. Okay, so just lay out all the transformation sequence here so that you can see. Okay, let's do number 7. Ooh, look at that. We have modulus functions. Okay, where's my cursor here? Hang on. Let me just close that. Okay. All right. Yeah, we need to sketch something first. I'm just gonna sketch here. Okay. A, sketch on separate diagrams the graph with equation. The first one is, okay, so y equals that. Oh, that's easy. So we get the coordinate axes first, and then x and y. So, well, if a is a positive constant, then that means this is moving to the right. And if you do 3x minus a equals 0, you're going to get the critical value. So x is a over 3. That means a over 3 is maybe around here, right? On the x-axis. And then you can do the V shape. That's what I do. That's how I do this kind of thing. Just find critical value. And that is where you get the vertex to touch on that point. There you go. Yeah. So that is the first part done, and we need to make sure that we coordinates of the minimum point. So this is a over 3, 0, and the coordinates of the graph crosses y-axis. So this is if we put x to 0, we get a. So that's a. Just try put x to 0. You get a, yeah. The separate diagram for B for II. Yeah, so this is just a follow-up question from I, really. It's just moving down by B. So, but we got to be careful, because if we just go random, let's say just go like that, we might get it wrong, because it says on the top of the question there, given that A and B are positive constants, but A greater than B. So when you have A greater than B, when you do A minus, when you move this down by B, it cannot go below 0, because B is less than A. It just like that, a little bit down, right? Not totally down to the other part. So we're just gonna maybe plot something like this, and then that just moving down, right? And this will be A minus B, right? Because we subtract B from A. And this vertex will be moved down as well. So A over 3, and then the y part is just minus B. There you go. Yeah, so we are done with this, part A. Okay, I think we're done, yeah. B, let's do B. Solve the equation that equals 5x. Given any solution, x in terms of A and B. Well, let's have a look at the graph we just drew first. That graph is just the second graph here we plotted, right, on the left part. So if we imagine it's like if we put them together on the same axes, we plot them together, we plot the two parts, left and right part. This is the left part and the right part. So it's like if we plot another graph here, y equals 5x. Yeah, so it's going to be a linear line like that. And now we got to be careful because y equals 5x, is it steeper or less steep? Well, if you look at the gradient part of the modulus function here is 3x. So 3x is less steep than 5x. That means my line here has got to be tilted so that it looks steeper like that. Just to get some sense where this will cut the V shape. And as you can see, they will never go meet to the right part of the axis here. And they won't meet anywhere here either. So the only point possible is somewhere between 0 and a over 3. So we expect only one answer from that. Okay? Okay, we're going to delete this later, right? Just give some idea. So how do we find this solution exactly without bothering about modulus sign there? I'm just going to selectively pick this line equation of the V shape. This is where the line has a negative gradient. So if we only take the modulus sign out, we get 3x minus a. And that is not a negative gradient linear equation. So that means when we take it out, we got to do a minus here to cover everything, and minus b. And then we are solving this equation instead. Yeah? So I'm just going to put minus 3x minus a minus b equals 5x. The answer will be exactly that point we want. All right, so we're just going to delete that line and solve this guy here. Sorry about that. So minus 3x plus a minus b equals 5x. Just to simplify, we move x on to the right side. We get 8x just to plus 3x on both sides. And then we have x equals, just divide by 8 across. And that is simply the answer, really. Okay. So that's only one answer there. If we give two solutions here, I think it's not going to be condoned. You're gonna lose marks if maybe you give more than one answer, because there is only one answer here, because it doesn't cut anywhere. Note that if you just don't care about the graph here and just do the algebra, most people would just go plus and minus for the modulus, and they thought that they would get two solutions, but sometimes it's wrong. Yeah, so it is safe to consider the diagram first, think about how many solutions that it should give you, and then go solve later selectively, because I just solved one set here. I didn't use the positive modulus there, if you know what I mean, right? And I'm done with that. So let's go do question 8. We're at 48 minutes. I think we're good. So 40, yeah. Okay, so question 8, I solve for that. Well, giving your answer in radians to 3 significant figures. Let me see. So cosec is a sine, so we have a cos sign there. Well, okay. So if I change a cosec to 1 over sine, so I have a sine theta here, and then I have a 8 cos theta there. So if you pull everything, you rearrange, you move 8 down here. Well, maybe I won't move 8 down here, I'll move just 4 down here, and I have 2 left here, right? It's like I split 8 into 2 times 4, and I move 4 down here instead. You won't know why I did that. So I get, on the right part, sine theta, cos theta here. And exactly, I can do a double angle formula here. So 2 sine theta cos theta is sine 2 theta. And sine 2 theta equals, on the other side, 3 over 4. So we can solve this. Now, but before we do, I always take some cautious measure here. I multiply the domain of theta there just to make it the same first, because we're going to use a cast diagram. So if we multiply by 2 across, we get 0 less than 2 theta less than 2 pi. This is the new domain. All right. So if we only do arcsine of 3 over 4 here, just to try find the first angle. Right, so we want to do in radians, so I'm just going to do radian here. Wait, hang on. Okay, let me try something out first, just to check my calculator, because sometimes it's quite tricky. Okay, I think that works. I have radian here. So we do arcsine of 3 over 4, yeah? and that is 0.84. We got to give it 3 significant figures, so I'm going to do 4 just to be safe, all right? Okay, so that's the first angle, really. So because that is the first angle, and we want all the angles possible, all the angles. So we have a cast diagram here. So this is our first angle, 0.8. So we got another one right here, right? Because you got to get a positive answer, 3/4. So that one is also right. So that means 2 theta, and that's it. You don't get anything else, because if you go down to quadrant 3 and 4, you get negative value. And that's probably it, because we just go one cycle here. So we get both that, and the other one is just pi minus that, right? So I do put its answer here first, and then pi minus answer. So I get 2.2935 to 4 decimal places, and then theta would be dividing across by 2 for both answers. So the second answer here first. Whoa, hang on. Okay, I'm just going to start over. 0.8481 divided by 2. I get 0.424. That's it. 3 significant figures. And then 2.2935 divided by 2. So when you want 3 significant figures, along the way you should do more, just to be safe. This is 3 significant figures, so I have 1, 5 here. Just, yeah. Okay. So that's it. That's the 2 answers there. Okay, now for II. Solve for 0 less than x less than 180, tan 2x minus tan blah, blah, blah. All right, so if you are quite familiar with the additional formula of tan x, right, you can check the formula sheet. Well, I just happen to remember that tan a minus b is just tan a minus tan b divided by 1 plus tan a tan b. Just like that, which is exactly what's on the left side. So this is basically tan, the whole left-hand side is tan 2x minus 70 degrees. That's it. Equals minus 3/8, right? Again, we want to solve this trig equation. We want to modify the domain first. So 0 minus 2x minus 70 degrees less than 180 times 2 minus 70. So that would be minus 70 here. Yeah, the lower bound of the domain. Okay. So is that right? I'm just checking. Yeah, so we get minus 70 degrees less than 2x minus 7 less than, this is 360 minus 7, so 290 degrees. Yep, happy with that. Again, so we're just going to solve for the first root, which is, yeah, we can do arctan. Oh, we got to get the degree now, so I'm just going to change the degree here, and arctan 3/8. So we get, yeah. So I do a positive root here because I want to get what's called a basic function, a basic angle, sorry. 20.55, 1 decimal place, so we can do 2, so 5, 6 here, degrees. So if you do the cast diagram, the 20.56 here tells you that if you want a negative tan, the possible quadrant is the second quadrant and the fourth quadrant here. 20 is just the basic angle closest to the x-axis. That's 20, that's 20. Yeah, like that. So that means 2x minus 70 degrees will have to be, the first answer would be measured from the x-axis anti-clockwise. Yeah. We can also do a negative first here because we can go negative. So we have one negative here being minus 20.5. Is it 6? Yeah, 5, 6. Yeah, can we go less than minus 70? I don't think so, because that would be more than minus 180. Okay, So the second one is going clockwise, or anti-clockwise to that. So that would be 180 minus that. So I'm just going to write 180 minus 20.56. Can we do more than that? Because we have the upper bound of 290. So if we want to do more, we got to go the other side. But that would be more than 300, right? Yeah, this reflex angle is more than 300. So we don't think so. So we're just going to get these two answers. That means x would be equal to, so I'm just going to minus, hang on, so fraction minus 20.56 plus 70, just solving that equation there, divide by 2, yeah? So the first answer is 24.72. 1 decimal place is 24.7 degrees. Second one, let's do that again. So this is 180 minus 20.556. And then we plus 70, move from the other side, all divided by 2. So that is 114.7, because 1 decimal place. And that's the answer there. 2 answers. Okay, I think I'm done with number 8. We're at about an hour now. I hope we get kind of like 2 or 3 questions left, which should be fine, I hope. Yeah, we have just 10 questions. Amazing. Wait, what? Yeah, just 10 questions, all right? Just checking. Number 9. Okay, I'm just going to do here already. Okay, so state the x-coordinate of P. Well, it seems like P has a y of 0 there. We're going to state, so if we put y of 0, that means we put y of 0 there, ln 4x, because ln 4, so we got to find either one must be 0. But ln 4x cannot be 0, can it? Well, actually it can, right? Okay, so yeah, hang on. Yeah, so this one should be 0 to make it 0, but because that would not be the coordinate of P, but I'm going to write anyway, so x equals 0. And the other one is ln 4x equals 0, right? Yeah, or that means x must be 1. Sorry, 1 over 4. Because when you solve the ln equation there, x equals 1 over 4, it multiplies, then it gives you ln 1, which is 0. Ln 1 is 0. So that means P, x coordinate of P is 1 over 4, yeah? And then B, the point Q shown in figure 1 is stationary point on C. Okay, so we use calculus to find the exact coordinate of Q. We differentiate, yeah? So we d by dx of fx first. So this is product rule because there are two functions producted together, if you know what that means. So we do u, that's the u, the first function. dv, we differentiate ln 4x, so we get 1 over 4x, but we got to do the chain rule inside the 4x, so we get 4, just differentiating 4x. u dv plus v, the ln 4x, not doing anything. And then because 6 square root x is 6x to the half. So if we differentiate that, we bring the power down to multiply, we get 3. And then that would be x power subtracted by 1 minus a half. Yeah? Got to be careful with that. Yeah, so if we simplify a little bit, we get 6 over root x here. Because if you simplify the root x and x here, you will subtract the power down here, and then you get the square root x down here. Plus, so this is 3 over square root x as well, because x to the minus half is square root over square root x there. And then I have ln 4x here. So we need to put that to 0 because Q is a turning point. All right. So dy by dx equals 0 equals that. Just writing down the working here just to get all the marks. All right, so how do we do this? If we multiply across by square root x, that's going to make 0 equals 6 plus 3 ln 4x, right? Because we know that square root x cannot be 0. And then we just solve, right? So we move everything. We make ln 4x the subject. So I get minus 6 divided by 3, which is minus 2, right? And then doing the trick again, you move ln to power the, to make it e to the power of minus 2. That's just, you can just do the e to the power on both sides, and that would work as well. But I'm just convenient like this. Okay. Yeah, so that would be x equals e to the minus 2 over 4. Yeah, exact coordinate. This is xq. So yq would be, just substitute this thing into the original function. So we get 6 of square root this whole thing. Okay, yeah, that would simplify. And then times ln of 4x is e to the minus 2 over 4. So square root this whole thing, square root e to the minus 2, you get e to the minus 1. Square root 4 down there, you get 2 down there. Just square root separately, maybe. And then don't forget we have a times here. So this is 4 cancel 4, ln e to the minus 2. Because the ln and the e are inverse functions, so you would have minus 2 here. It's like I have ln e to the x would be equal to x. So whatever is x here, you're going to get just x as a result of that exponent of that log, yeah? So 2 here cancel with the minus 2, you get minus 1 here, and that is just minus 6 over e, simplifying everything. So that's my exact y coordinate. That means the q here is x e to the minus 2 over 4, comma, minus 6 over e. That is the answer. Okay? Just make sure that they can read my handwriting here. And by they, I mean myself, because I'm going to mark this paper later on. And then we have question C to do. Hang on. Hence, find the range of the function gx. Okay, so this is the technique in P3 and probably in all the papers. When they give you the graph, use the graph because it speaks volume about whatever you want to find here. You want to find the range. Look at the graph. Let me show you. The range is just simply goes like that. So it starts from this point because there's nothing below that. There is no line below that. So the minimum y should be this, the y coordinate of q. We already found that. And then it goes up forever because there is no limitation to the domain. That means the y starts here and goes up forever. Or y is greater than this value here, right? That's it. So, oh, hang on. Sorry. That is not the function I meant. It is just, we have to multiply that by 2 first. Sorry, okay. That won't be hard. So we find gx first. Minus 2 times everything. So, because we already know that the range of f, is going to start from q as I was just talking about it. So the range of f is just y greater or equal the y coordinate of q, which is minus 6 over e. We just found it up there. But we want to find the range of g. So therefore, the range of g, well, when you multiply the whole thing by minus 2, this thing will flip, yeah? This whole graph, if you multiply this whole thing by minus 2, because that is the gx, the whole thing will flip and enlarge by a factor of 2. So it's going to be flipped and then go up more than it goes down, like that. Okay, if you imagine, and this should be vertically aligned, I mean. So this point will have the x coordinate will be the same, which is whatever that is. And then the y coordinate will be just 2 times, but positive value. So 2 times here, 2 times the minus 6 over e, so would be 12 over e with a plus sign. I made a mistake about this before, right? So it becomes a positive now, 12 over e. So that means instead of being more than this negative value, it got to be less than this positive value. So y must be less than 12 over e instead. Yeah, this is the range of g. Yeah? So I'm just going to show the working here, minus 2 times minus 6 over e to get this, basically. All right, and that's it. That's our range. We are done. Now on to the last question of this paper. Not bad, not bad. Okay. Question A, dx by dy in terms of y. We get a parametric. No, not a parametric. It's just some graph here. So we're just going to do hang on. Dx by dy. Because x is already the subject. So we're going to use chain rule because there is a 2 with a y there. Right, so 3, differentiate cos, we get a minus sign, so I get a minus sign here, sine 2y, sorry. And then I got to pull 2 out, so I multiplied by 2. So I have a minus 6 sine 2y. And because I want dy by dx, so that's the answer, yeah? And hence show that dy by dx is just the flip of that. So let me flip that first. Okay, I'm just going to do minus here in front of everything. Like that. Now, because the form that it wants doesn't seem to be the same as the form I have right now, so what do I need to do? I need to derive this into the Cartesian. This is a trig form, it's not a Cartesian x and y, right? Sorry, this is a trig function, it's not a polynomial. We want polynomial, right? So what do? Well, we can see that x is 3 cos 2y. So usually you can sort of like think about trig identities, right? So because trig identities can be used for any angle, not just x or theta or a. I can do sine squared 2y plus cos squared 2y equals 1, right? So that means if I want sine 2y alone, I would have 1 minus cos squared 2y and then square root. You see, that's where the square root comes from, right? But because we already know that if you make cos 2y the subject from the original equation there, you're going to get x over 3, yeah? Just try follow that. So if we plug this into the square root, we get sine of 2y equals 1 minus x squared over 9, right? Just square that to 2y thing. And if you put, 1 over 9 outside the square root, you're going to get, sorry, not 1 over 9, 1 over 9 in the square root first, but outside the whole thing. You're going to get 9 here minus x squared here, yeah? And then you can take the 1 over 9 outside the square root, that would become square rooted first. So it's 1 over 3. And then you can take the whole thing like that. So this is just derived for sine 2y. So now dy by dx, we can say that it is minus, I don't forget the minus there, 1 over 6 times sine 2y is 1/3 square root of all that, right? Okay, it's constant to be found. So I need to tidy up to make it look like the same form. So 3 cancel with 6, here we get 2. But I need to make, so if you pull that up, you get 1 over 2 up there with a minus sign. Okay, yeah. K is just a constant, it doesn't say integer. So this is fine, I hope. And then square root that. Yeah, so exactly like the form. Just that K is not an integer, which is fine. Okay. So I guess that's fine. The point PAB lies on the curve and is shown in figure 2. So in figure 2, yeah, we can see that point PAB is that. The gradient of the curve at P is 1 minus 1 over 4. Point A and B are positive. Okay, so because it says the gradient is minus 1 over 4, and that is the point of the derivative function dy by dx. So we equate dy by dx equals minus 1 over 4. That is the gradient of the curve at point P. So we're just going to take the whole equation here we just found in A, equate to that, yeah? All right. So we solve. So if we make the square root term the subject here on the left side, I am moving minus, so I multiply by -4 both sides, I get 2 on the right side. All right. I hope that's fine. Okay. So yeah, so how do we make this 2? All right. So the way we solve this is probably to square root both sides. So we get 9 minus x squared equals 4. So x squared must be 5. And that means x is plus or minus root 5. But because the x coordinate of p must be a positive, so we just take x equals root 5 as x greater than 0 here. Yeah? So that's a. So a equals root 5. And for the b part, we just insert x back to the original function. So root 5 equals 3 cos 2 y. And when we solve for y, we're going to get b. So we get cos 2y equals root 5 over 3, right? We want to find the exact value. Interesting. How do we get exact value for that? Okay. Interesting, yeah? Is it root 5 indeed? 5, 4. I start to think maybe there's something wrong here. Because, well, let's see. So if I do arc cos, so this should be a radian. So I do radian here. And then arc cos, root 5 over 3. That's not exact. I'm in trouble somehow. I gotta double check my work earlier, right? So dx by dy is 3. Differentiate cos, we get a minus sign. Chain rule, get minus 6 sine 2 y. That should be fine, I think. Dy by dx, we flip this. Yeah, so we get the whole thing on the bottom part. And then we do the trig identity here. Make 2 sine 2y the subject. And because cos 2y is x over 3, we square that, we get this. We pull 1 over 9 out of that first. That should be fine. We pull this out, we get 1 over 3 for sine 2y. We solve this whole thing back to sine 2y here. So I get that. This cancels to be 2 here. So this is minus 1 over 2 up here. That should be fine. dy by dx. The gradient of the curve at that point is minus 1 over 4. And then this is minus 1 over 2. So when I multiply by minus 4, that's going to be 1. That's going to be 2. And then I multiply this to this side, I get this. I square this, I get this. This should be 5. That should be square root 5. What's wrong with this? I haven't seen it yet. Okay, let me check the whole paper. There's no specification about a mistake, so maybe the mistake is mine somewhere. Okay, I have some time to figure out what I did wrong, so I will try hunt down my mistake. I mean, if you found it already, that's good for you. But I'll do some commenting in the editing. Right. I think it should be in terms of like root 3, a multiple of root 3 here, because it might cancel with this, and then you know about cos of some angle equals maybe root 3 over 2 or root 3. Maybe root 3 over 2. Yeah, so Maybe the k value is wrong. Differentiate cos, get a minus sign. I'm still not sure with all this, right? I 1 over minus 1 over 6 sine 2y. So you put this whole thing to this. Yeah, again, this is the same process. I've seen it already. So you get, it's like you get a 2 down here, and then I pull it up. So k should be minus a half. Yeah, this is the same process. I mean, I haven't seen my mistake yet. I hope I do. I'm trying to find it with an open mind, actually. Okay, we got 13 minutes left. I hope I can go back to check that first. Check everything I've done for earlier questions. But this is the last question anyway, so I'm kind of chill. Could that be a negative? That could be a negative, right? That could be. Yeah? Well, let's assume that is a negative value, right? See what's going to happen there. Yeah, because it says here that x can be positive or negative. So let's say x is negative, that means cos 2y is negative. If cos 2y negative, sine should be positive anyway. So sine 2y, so if we consider the range here, it's going to be from 0 to pi, which is always positive. Cos could be negative, however, if y goes beyond pi over 4. So, but if cos is negative, that's going to be positive anyway. That doesn't matter. So yeah, this whole thing should be positive. Right. Doesn't help. I think I gotta make do with what I have here. How do I solve this? Yeah, it doesn't look like I can solve this easily. So this is basically arc cos of it's basically 1 over 2 arc cos root 5 over 3. I mean, if it wants exact, that's the best exact value I can give it. So b is just 1 over 2 arc cos root 5 over 3. I'm not sure if this is right, but I mean, my sense is telling me that it shouldn't be in terms of an arc function. It should be just an irrational number, maybe, or something. I mean, if I run out of time, then I'm just gonna go with that. But yeah, I don't know. Yeah. But okay, let's play around with this equation first, right? Because x is root 5. So then, okay, because I think I'm sick of double checking already, so I'm just gonna try play around with this. Let's keep that as the backup answer when we run out of time. So I'm just gonna go deeper with that. So this is okay. Yeah. Right. Okay. So let's do 1 minus 2 sine squared y, right? Just gonna play around with that. 3 minus 6 sine squared y. So I'm just using double angle there. Okay, so 6 sine squared y equals 3 minus root 5. That doesn't seem right. I mean, okay, let's try go along. See if I put this in a calculator and it happens to be an exact angle for me. I hope. So if we do arcsine fraction, 3 minus root 5 over 6. Not an exact angle. That's horrible. Yeah, I don't know. Yeah, maybe not that, right? So we're just gonna go with that answer. I think I'm kind of out of brain here. I don't know. If we assume that I haven't done anything wrong, then can we try cos? Can we try tan? Can we try anything else? Probably not. Yeah. Wait. Wait, if we put to this original function 1 minus 1 over 4 equals minus that. Hang on. Sine 2y equals 2 over 3. 2 over 3? Really? Yeah, I mean, if I already put this into the dy by dx, it doesn't seem to be... So if we could solve for y here, but that's... If you try put arcsine 2 over 3, never going to be an exact values. No. Something is blocking my vision here. I don't know. Yeah. Okay, I could do y equals... So this is part C. Y equals arcsine 2 over 3 divided by 2. So maybe I will use that answer instead, right? Instead of this. All right, let's do that instead. Yeah, so I'm gonna cut that and put it here instead. All right. Yeah. So that is also B. Yeah, I'm gonna go with that, you know. I think I'm done with all the questions, but I'm just gonna double check everything because I have like 5 minutes to go. So let's do that. Okay. I think this is fine. So let's try double check that. 2 over cos of 0.1, just randomly checking here, plus 6 times 0.1 minus 3. That is fine. Yeah, change of sign, continuous. And then we got the iterative formula. That should be fine. Number 2, that should be fine. Put t equals 0 and then 10 to the 1, so we get a equals 10. We solve that by putting 25 into the a and move everything. So for t, that should be fine. We do the quotient rule here. Let me look at the time. We're still fine. Okay. Quotient rule, v du minus u dv over v squared. Okay. And then we put it greater than 0. We take the x plus 3 out here. Yeah. Flip the sign, get the range. That should be fine. Number 4, division, long division of polynomials function. I think I did all the division quite fine here. Yeah. A, B, C. Yeah. All right. Yeah, from the long division. Okay. And then part B for number 4. Yeah, we just know that it is a reverse chain rule, so we just try integrate this separately first, and then we put the bounds in. So we're quite fine with that. We can simplify it to that. Yeah, so that's good. Number 5. I think we're fine with this. Oh, I did B down here. Yeah. Yeah, we plot that already. We state the asymptote equation. Okay, that's fine. 24 is the asymptote. Right. Ooh. Ooh. It says t greater than 0, so I shouldn't have this part. Yeah, I should cut this out. There you go. Phew, almost there. Right. Yeah. Okay, I mean, if there were a harsh examiner, they shouldn't give you mark there. I mean, yeah, I wouldn't either. And let's check the significant figures, decimal places, and everything. Yeah, this is fine. Okay, number 6. Yeah, plotting. Wait, number 6, not 7. Okay, so I'm just going to skip the inverse part there because I think it's fine here. Number 7, plotting, move down, solving, that should be fine. Number 8, trig equations. Just want to check the decimal place here. All one decimal place, 3 significant figures, so I'm fine with that. Number 9, these functions thing. I think I'm also fine with that. And number 10 was the real problem there. Yeah, so I don't know. It says exact values, so yeah, so you know what? I'm just gonna, just in case, so sine of 2 over 3 and then divide by 2. I'm just gonna write the answer to that first, just in case, right? 3, 6, 4, 8, 6, 4, 9. It's not exact, but yeah, I'm just gonna write that. All right. Okay, I think I'm done here. I'm gonna stop the timer. Stop, because I'm out of time. Let's mark the paper. Okay, let's mark the paper. This is the mark scheme for P3, January 2025. All right, let's go through it together, guys. Number 1. Yeah, so A was, what was A? To 0.24 and minus, yeah, there is a change of sign continuous, hence there is a root. And the question here is 1 over 2, 1 over 3 over sec. It's the same thing. Yeah, I got it. This is 0.1622. Okay, so number 1 was fine. Number 2, 10 meters squared, 13.26 weeks. Number 3, dy by dx, and then critical value is 5 over 2 and minus 3, so I got the range there. Okay, number 4, yeah, I did the long division. Yeah, they also allowed that. So A is 4, B is 2, C is minus 13, and D is 0. So yeah, I think, let's have a look at this, because I already did long division, e.g. using, so see if they allow it. Fully shows that D equals 0 from clear work. Using division to working must be fully correct with the remainder shown as minus 13. Yeah, okay. So I got that. And then B, so 36, 13 ln 2. Yeah, that's fine. That was the integration bit. Number 5, 104 Celsius, and then I got the graph here, asymptote being h equals 24, and this is the initial point, so that was fine for the graph, 16.95 minutes, 1.2 minus 0.05 h, yeah, that's cool. 6a, yeah, I wrote the domain, x not equal 4, and then the equation is 2x plus 3 over x minus 4, so that's fine. 19x plus 6, and then 2x plus 7, 138. So yeah, I got all of those. Number 7, shape, I got it. This is a over 3 and 0. That's fine. This is a minus 0, a minus b. This is a over 3 minus b, so that's also fine. A minus b over 8 only, that's fine. Number 8, so solve, right? So what was the answer? Yeah, these two. Okay, cool. And then 24.7, 114.7. So that was fine as well. Number 9, 1 over 4 for the xp, fine. And then this is e to the over 4 minus e to minus e over 6, fine. 12 over e, fine. Yeah, that's less than, must be less than, yeah. Number 10, yeah, number 10 was the tricky one. I took some time to just figure out the last part, yeah, but the other part should be fine because I managed to show what they want. Oh, here we go. What's wrong with this now? Yeah, this is still fine, yeah. Okay, for B. For C, yeah, see, wait, for B, hang on. Wait, this is C, yeah, I don't think I think this is okay. They're not gonna penalize. I just wrote the wrong letter there. Should have been C. So A is root 5, I got it. But yeah, this one. So okay, they do have an arc sign. Yeah, they do have this. So I think I got that one because I asterisk. So I do a hatch for that one. Oh, so I didn't lose any marks. Perfect for this one. Like perfect, full marks, raw score. No doubt for the UMS then, but let's check the UMS. Okay, so this is the UMS calculator page. I change it. I got to change it to P3. Then let's put 75. Of course, you see 100. If I put 74, 73, 72, 71, 70. Yeah, so the minimum mark to get a full 100 UMS is 71 for this paper. All right, so I would have had still some margin to lose some marks there, but yeah, okay. Let's do feedback. Gotta write my marks first. 75 over 75. Okay, pretty proud of that one. Okay, so Yeah, I think this one was easier than the October 2024. Quite easier, in my opinion. The only tricky bit I would say is yeah, you know, this one, the integration. So this one, if you don't know the reverse chain rule, where if you integrate a function, like if you see that the numerator is kind of like a multiple of the derivative of the denominator, whenever you see this, yeah, you should try differentiate the denominator. Is you try differentiate the denominator, you get 2x here, and 2x is kind of like a multiple of minus 13x, right? So if you, whenever you see this, you should try differentiate and do like I did here. So I put minus 13 over 2 here to correct the factor, so that when you multiply this, you get it back to minus 13. And this very factor is going to be the factor that you put, yeah, the form that you integrate this, you get a ln fx. You can try differentiate ln fx here. You're going to, by using a chain rule, you're going to get f prime over fx, like that. So this is a reverse chain rule, right? Bear this formula in mind. And there's another one where you have integral derivative of fx, but fx itself is the power of n. This is where you try some factor after you do something like this bit here, and then it would be fx to the n plus 1, right, for that one. So you have these two main forms that would make P3 kind of tricky in this kind of calculus question, right? Always beware of these two forms. I call them tricky forms, actually, right? The two tricky forms in P3. If you know them, it's going to make this quite smooth, and it's not going to cause you any problem. So just bear those in mind, right? So this one is exponential, so I guess this is fine for most people. Yeah. It's just that, yeah, this is the thing. When they ask you to show like this, some other questions from some past years, they did it more difficult than this. Sometimes they have h and then h plus something, for example, over something. But basically what you need to do here, when you differentiate an exponential form, you get an exponential. So you substitute that exponential, or you eliminate it by just, isolate it from the original equation. That is usually the way. And you sub it back to this form, right? So, and then you derive, you simplify, you're going to get what they want there. Yeah, just try a little further there on that. This one is fine, just normal reciprocal function, and some transformation at the end. So that shouldn't be a problem there for you guys. Yeah, this one you got to be careful, right? So when you solve for, I guess some people might make a mistake where they put an a rather than an a over 3. So it's not about the number that you see here for the intercept. It's about putting the whole thing equals 0, because this is when y equals 0. That's why you put the whole thing equals 0 here and solve for it. You get the critical value. That is where the line cuts the axis, right? All right, and yeah, the rest is fine. This one, solve trig equation. Yeah, gotta be careful with the cast diagrams, guys. And this one, yeah, is no, not this one. This one is still fine, yeah. So you gotta be careful with the range when you flip the thing. I used to make one mistake about this. I didn't change the sign. So it was negative before Q, and then it's flipped up, and then it was enlarged, so it should become a positive too, right, for that one. So yeah, this one, okay. So this kind of answer, exact form to be arc trig function, it's a bit rare to me. So maybe one of very few times that I see this happen, or the first time at all, actually. Yeah, so it is possible to get an exact value to be some arc trig function, right? And the rest was fine, I think. So there's no problem there. I hope that was useful. I'll see you in the next one.